Welcome back to 11.7. This is Kirchhoff's junction rule, daily video 2, where we're going to take our junction rule and combined with our loop rule to solve some more complex circuits. My name is Dr. Kelly Miza. I teach at Delaware Valley Regional High School in Frenchtown, New Jersey. Alrighty, let's review before we move on. So last time we talked about the junction rule, which basically shakes out to current going in equals the current coming out of a junction in our circuit. We also had our loop rule back in 11.6, where a complete loop around a circuit has a potential difference of 0. As a refresher, here's the steps for how do we make our Kirchhoff loops. We choose our starting point, sketch in our currents, sketch in our loops, and then we follow our loop to add up all of our voltages. Here's that nice little chart again. So if you're going through a battery from negative to positive, you add the voltage. If you're going against the battery from positive to negative, you subtract the voltage. If you go through a resistor in the same direction as the current, that's a negative contribution. And if you go through a resistor in the opposite direction of your current, that's a positive contribution. So let's do a practice problem to see how this all comes together. Okay, so let's look at this example. So if we look at this, we have actually 3 loops that we can follow. We can start here and go woo this way. I'm going to call that loop number 1. We can start here and go woo back to where we started. I'm going to call that loop number 2. Or we can go all the way around the outside. So if I start at the same place, I can go woo all the way around the outside. I'm going to call that loop number 3. So we chose our starting points. We drew our loops. Now we just need to draw our currents. So I'm going to do my currents as nice straight lines. So I'm also going to start at my junctions. So if I start at this junction right here, and we also have this junction right here, I'm going to say that the current that comes out of this junction and travels this way, I'm going to put arrows on each of those nice little branches so it's very clear which way it's going. I'm going to call that current number 1. So everywhere on this branch gets that same current. Once it gets to here, I can have another current that goes this way. I'm going to call that current number 2. And I can also have a current that comes this way. I'm going to call that current number 3. So once you get more than one loop, it gets a little bit squirrely seeing what's going on, but then we can follow our nice fun things. So as we have our junctions down here, we have I1 going clockwise through this branch, I2 coming down, and I3 going clockwise through that branch. I'm going to go to the next slide so we have a little bit more space to work. So our very first loop, I'm going to follow this inside loop. That goes this way. That's current number 1. Here's current number 2. So here are the 2 relevant currents for the loop that I wanted to follow. So we started here and we went this way. So if I start at my star and I follow my loop, I hit this battery, whoop, I get that boost. So I have a positive voltage contribution from battery number 1. And then I cruise on over, I hit R2. And since my loop and my current I1 are in the same direction, that's a negative I1, R1 contribution from there. Then I continue to follow my loop and I go through resistor number 2 in the same direction as the current, but now that's current number 2 that's going through there. So that's a minus I2, R2. And then we get back to where we started, so that's going to be equal to 0. All right, I'm going to sketch I3 back in again. So there was our I3. And now this time, let's follow this right loop. So that right loop, we started here and we went this way around our loop. So let's write that one out. So we start here and we get boosted by battery 2 because we're going from negative to positive. So it's going to be a plus V2. Blink. And then when we come down through R2, we're going in the same direction as the current. So it's going to be minus I2, R2, and we get back to where we started. So that's going to be equal to 0. All right, last but not least, let's do that outer loop just so we can get that extra practice. So if I follow that outer loop, I start at my star, I hit battery number 1, so I get a boost by battery 1. I hit resistor 1, and I'm going in the same direction as I1. So it's going to be minus I1 R1. And now since I'm following the outer loop, I'm going to go this way. I hit battery 2 at the positive terminal and head towards the negative terminal. That's going to be minus V2. And then I get back to where I started. So that's going to be equal to 0. All right, now let's take a look at our junctions. So we have a junction here and a junction here. And just like our example earlier, these are going to end up giving us the same expressions for our junctions. So our junction up here, if we look at who's coming into the junction, we have current 1 coming in. So we also know that current number 1 is going into my junction, and current 2 and 3 are coming out of this junction. So from here, we have a completely solvable system of equations, depending on what you're trying to figure out. So if, say, we were trying to figure out, well, what's the voltage of battery number 2? Well, that's going to be equal to current 2 times R2. Or if I wanted to figure out what are currents 2 and 3 based on I1. So depending what you're trying to ask is going to depend on what you solve for from here. But we have a fully solvable system, which we've made out of our loops and from our junctions. So what should we take away from this? Kirchhoff's loop rule and Kirchhoff's junction rule are very powerful tools that can solve more complex circuits that you cannot solve just by finding an equivalent resistance. Situations like multiple batteries, or if you end up with some resistors kind of crisscrossing all weird ways that you can't smush them together into parallel and series situations, Kirchhoff's loop rule and Kirchhoff's junction rule are there to save the day. Thanks.